Hi guys, welcome to this video on linear representations of nonlinear relations. Another very long title. My name's Darren Maffs, really good to see you. Thank you very much for joining me. Hopefully you are well. Please do me a favor and like this video. Apparently YouTube likes, and not many people like my videos, which probably means no one's watching my videos. Anyway, if you can, head over to YouTube and subscribe. There's maffsguru.com as well, where you can download notes and exam questions and so much more. Time codes, videos, blah, 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 blah. What are my learning objectives? Understand how to find the equation of a non-linear function. Believe it or not, you have already done this in the course section. So when you remember, we gave you the data and we basically told you to linearize it to find the line of best fit. Well, all of the examples we gave you in the data section, the statistics section, generally speaking, weren't going to be a straight line. All right, that wasn't the point of it. We wanted you to get a line of best fit so we could predict. That's fine. Now, the good news is, all of the work we're going to do is going to actually turn curved dots into straight lines, and we can find actual straight line graphs and all that type of stuff. Yeah, makes sense? No, not really. Let's do two examples. I'm going to use my CAS for pretty much most of it, but you can do it by hand as well. So for example, this question here, which comes from Cambridge, and thank you very much for allowing me to use your examples, says the best way to do this is to look at an example. A table of values is shown. First thing it asks you to do was plot the points determined by the table. So we had points here, and ideally what they wanted you to do was draw a graph. So you have x values 1, 2, 3, and 4. 1, 2, 3, and 4. And then we had 1.5 all the way up to 24. So 5, 10, 15, 20, 25. And then 1 was at about 1.5, so it's there. 2 was at about 6, which is there. 3 was at 13.5, which is about there. 4 was at 24. And again, you, if you were ever expected to do this, would do this accurately, because you'd have square lines and whatever else. Then it says plot the graph of y against x squared and y against x cubed. Now, what that really wanted you to do then was actually plot your value of y against x squared. Well, you don't have the values of x squared, do you? Nope. So you would be adding an extra row to here and taking all of your x values of squaring them. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. All right. So now we wouldn't be plotting the values 1, 2, 3, 4. We'd be plotting the values 1, 4, 9, 16. But we're going to make sure. So we have 5, 10, 15, 20. 5, 10, 15, 20, and we plot those points. And then we do the same for x cubed. Now doing this by hand is painful, you think? Right, so what I'm going to do now is share how to do it on the CAS. Let's close down all of the things we had before. I keep hitting the wrong screen, so it's delete and delete. Yes, I want to delete. Hit menu, press menu. What I'm going to do now is put in a list and spreadsheet. So I'm going to put the data, my original data in there, and if you remember, we do x and y. So if you don't remember this, this is going to be great revision. My x values are 1, 2, 3, and 4. And my y values initially were 1.5, 6, 13.5, and 24. Now, if you remember, we can get our graph, our calculator to draw those points. So this is now how to do that first part. So what am I now going to do? Control and insert, and I want data and statistics. Now your calculator says, well, hold on, click to add a variable. It doesn't know what's going to put where. So on my here, I want my x values, and here I want my y values. And ka-ching, what do we notice? We've got that curve. Yeah. So theoretically, I could plot those in. I think if I put my, hand over it, you notice it gives me each of those values of my coordinates. Well, that's obviously not straight. How will I now do my graph of y equals x squared? Easy. Go back to my table. I'm now going to say x square, and I'm going to say, can you now put, work out my square values of x? And if you remember, we want to do x and squared. The calculator is asking me, do I have a variable reference? And there we go. There's my numbers 1, 4, 9, and 16. What do? I flick back to my screen here. I now change my bottom variable from x to x squared. And what do you notice? Woof! That seems to have turned that into a fairly nice straight line, he says. We'll check in just a moment. What about doing my x cubed graph? Because it wanted me to do both. Well, funny enough, go back. I'm now going to type xq, xcu, hit equals there, and now do x to the power of floaty 3. Again, the question says, is it a variable reference? It is. And there's my x cubed values. What do? I go back to my graph, Hit X squirt now and do XQ. And there we go. Is that straight? No, that seems to be doing this. So, for us to be able to determine the equation, we're looking at using the one where the points are straight. So I'm actually going to go back to my X square and turn those points straight. And then we go back to the core stuff, right? So it says determine the rule connecting it. Now, at this moment in time, we have a graph of y and x squared. So if I now do a regression analysis, which is nothing more than finding the line of best fit by doing menu, analyze, regression, and in this situation I'm actually going to choose mx plus b. We want the equation in the form of y equals mx plus c or whatever else, and ladies and gentlemen, ka-ching, there is my answer. Now, just because we've been tricked on this before, let's not be tricked. Although the equation on that screen is saying y is equal to 1.5x plus 0, he says writing it where you can't see, so let's do that. Y is equal to 1.5x plus 0. Remember, this value of x isn't, it's x squared, because that's what we've plotted on the bottom. So, minimizing this so that you can actually see what's going on, we would now know that the equation would be given by y is equal to 1.5x squared. So each of these points is given by the x value squared, and then you times it by 1.5. Whoa, ka-ching, yes? So the trick here is linearize the data, do the regression analysis, and effectively read off the equation, and you've done all the hard work. Here we go, here's another example. The table of values determined of the rule now give you y equals kx squared plus c. Plot the graph. Now, they've given me the hint here of what I actually have to do in my data. Whereas before they said do x squared, do x cubed, they're actually telling you that the equation has some relationship between y and x squared. All right, so there's my y value, and I've got to do my x squared. So that's what I'm going to use to help me do my graph. Fire up my CAS again, covers over the screen, but we will now go Control and up, delete those, yes please. Insert, list and spread. And obviously you don't need to do this. I'm just doing this for completeness really. So what are the values again? 1, 3, 5, and 7. And we're going to go up and put my y values in 0.5, 3, 23, 63, and yep, 123. And I've realized I actually started there at 0, 1, 3, 5, and 7. Only human. Now, I'm not going to draw that graph, I don't need to, because it says draw the graph of y against x squared. So let's do that. I'm going to do x square, because I need to call it something, equals, take my x variable and square it. And yes, once again, it's going to ask me for my variable reference. And fairly repetitively, Control and I, let's have some data and statistics. Oh, does that look like my graph? Nope, because I've got to add my variable. So we're going to do, what do we have? X squared on the bottom, y up the side. Is that straight line? Yes, it is. Oh, very exciting. All right, now what are we going to do? I need to do menu, analyze, regression. Let's do that one there. And once again, remember that although your calculator is giving you y is equal to 2.5x plus 0.5, is it x? No, because what's on my x-axis? It is x squared. And ladies and gentlemen, my value of k, therefore, would be 2.5, and the value of c would be 0.5. And that is that for this video. Thank you very much for watching. If you can do me the honor, please, of liking the video, subscribing, and telling your mates. Nobody watches maths videos. Never going to be rich, never going to be famous, but with your help, hopefully other people will find my channel. If not, hopefully see you again. Take care, guys. See you again. 2 more minutes of this video left. Please take the time to watch it. See you again. Bye-bye. Thanks very much for watching, guys. Yes, this is the end of another video. If you haven't already done so, can you click on my subscribe button? Yes, it doesn't mean anything other than the fact that I know that you are watching. Yes, it's greatly appreciated. Otherwise, I feel like I'm sitting here just talking to myself. And then, yes, there is maffsguru.com, of which you can see a still of now. And what is over there? Well, all the videos ordered by textbook, ordered by topic. You can search for the videos. You can download notes, time codes, exam questions, and so much more coming up. Yeah, it's absolutely free to join. So I'm done. Thank you very much. I hope to see you in another video. Give me a shout out to your mates if you can. I just want to make sure that everyone finds maths interesting and easy. All right, take care, guys. See you again. Bye-bye. Stay safe.